Problem. A bullet hits a tree and penetrates it to 80 centimeters depth. Initial speed of the bullet is 800 meters per second. Question. Find the time of bullet traveling inside the tree. Find acceleration and also in the middle of its way in the point A. Find the speed in point A and find time from starting penetrating the tree to the point A. So we can see that since bullet penetrates the tree, it slows down and it stops. So final velocity is 0. Pay attention to units of measure. Since we have negative acceleration, so we choose x-axis to the direction of the bullet, so velocity is positive, acceleration negative. Opposite directions, that means bullet is slowing down. Now let's use the standard formula for to find acceleration. The standard formula is final velocity minus initial, both squared, equals 2a delta s. For the whole trip from O to B, final velocity is 0. So in this formula we have total distance is the depth. So we have our acceleration negative 400 kilometers per second squared. So acceleration is negative because it's opposite to the x-axis. The total time, we use the standard formula where by definition acceleration is the ratio of change of speed and change of time. Here we have our total time is 2 milliseconds. To find time and velocity in any point between O and B, we also use these formulas. Remember, we said that we can take just a piece of the whole move, and for that specific piece we'll have its own delta S, delta T, final velocity, initial velocity. So for point A, which is half the distance, we have distance 40 centimeters here, the same acceleration, and final velocity we actually have to find. Initial velocity is 800 meters per second. We plug in numbers, we find the final velocity. So this is final velocity V1 is for point A. The same we do with time. So time would be 0.586 milliseconds. Now let's notice that this D1 from A to B is a half of the whole depth. 40 centimeters is a half of 80 centimeters. However, the time that's spent on the first half is much less than time spent on the second half. Total time 2 milliseconds, but on the first half of the distance we spent 1/4 of the total time, simply because in here velocity is much higher, body slows down, so on the first half velocity is higher, on the second half velocity is lower. Graphs. Change of coordinate, function of time, velocity, function of time. On this graph we see that at the initial point O, we have initial velocity is a tangent of the angle of inclination of the graph to the horizontal axis of time. And the final velocity, we can see that the angle of inclination of the graph to horizontal line in point B is actually 0, and in trigonometry tangent of 0 is 0. Our final velocity is 0. Graph of velocity. Straight line, linear function. Velocity goes down. Initial velocity 800 meters, final velocity 0. And this is velocity at point A, and we can see it's still high because it's the first half. We know that the distance in general is area below the graph of velocity. So we can see this triangle AOAB, and area of triangle is half base times altitude. Stick in numbers and we'll get our delta S exactly 80 centimeters or 8.0 meters, which is exactly the depth of penetration of the bullet.